In this video, we'll discuss present value. Now, present value is the current value of a sum of money instead of what it will be worth at a future point. So if you think about all those times we've been calculating like compound interest, we've been calculating what's its future value. In this case, we may know the future value and we want to determine what's the current value. So when would this happen? Why would we care about it? Often this happens with things like bonds, where we have some investment that we know will mature to a certain amount at a given time, and we want to determine, well, what's its current value if we needed to sell it now for some reason. So let's go back to what we talked about with compound interest a few sections ago. And in that we said that we have this formula where we know the future value is equal to the principal times the quantity 1 plus the rate divided by how many times it's being compounded, raised to the number of compounds times the time that will pass. So when we think about this equation, in this case, when we think about present value, we know this future value. What we want to know in essence is the principal. Where are we starting? In other words, where are we now? That is what's considered the present value in this equation. So then we may ask ourselves, well, how do we rewrite this? Well, if you think about this as being P, the present value, times this whole quantity, since that's multiplication to that whole quantity, I can divide both sides by that quantity, and that will simplify the right-hand side to 1, leave me with the present value equaling the future value divided by that whole quantity. And that's the formula for present value. You're going to take your future value and divide it by that whole quantity that has our compounding with the rate over time. So the parts there are still the same. It's just we've rewritten this equation to solve specifically for present value. Let's look at an example to see how to do this. So again, we're going to have our formula up here to help us. Say we have a bond that will be cashed for $5,000 exactly 5 years from today. If the bond uses a discount rate of 4.5% compounded quarterly, what is the present value of the bond? And round that to the nearest cent. So we can go through and find all the same information like we would if it was a compound interest problem. The difference is we actually know the future rate. It's $5,000. Then we don't know the present value. So in other words, we don't know that principal, which is the present value in this case. Then we look and say, okay, we do have the interest rate of 4.5%, but we've got to remember that's a decimal, so 45 thousandths. We know how many years are going to pass, which is 5 years. And now we also know that we're compounding quarterly. So that's 4 times a year. So now we have our information we can substitute into our equation. So 5,000 goes in our numerator. And we have the 45 thousandths divided by 4. And then it's that 4 times the years, 5. I'm going to simplify these two together. So this becomes 1,125 hundred thousandths. And 4 times 5 is raised to the 20th. So now I just raised this, my 1 in 1,125 hundred thousandths to the 20th. And then we'll divide 5,000 by that value. And here I've rounded to the cent, and that's $3,997.60. That means that if I sold this bond today, because I had to for any reason, its current value should be about $3,997.60. So if someone's trying to give me a much lower value than that, I wouldn't want to take it. Now, we can also talk about the idea of cashing a bond early. And we know, well, how do we figure out some of that if it's already partly into bonds? Because you typically buy a bond at some number of years. 2, 5, 10, 15, 20 years. They're sold by governments, by states, by corporations. So say that you're like several years into it and you want to know what's its exact value at that point. We're no longer at a starting point. We're at a very specific point in the bond. So its value has changed from when we started. So what we can do is we can calculate that present value using the formula like we just did as if we went to full length of the bond. That will tell us where we started. Then we can use that as the principal in the compound interest formula based on the number of years that have passed. So this is a two-step process. First, we need to determine what's the principal or the present value if it was a full-term bond, and then we can use the compound interest with how much time has passed. So let's look at this example where Erica is 4 years into a 10-year bond that would pay $15,000, but she needs to sell it right now. What's the current value of the bond if she used a discount rate of 3% compounded semi-annually? And we want to round to the nearest cent, so that's to the hundredth. So let's go through and get everything we know in this problem. We know that eventually it will be worth $15,000 when it matures. We know that we're trying to determine its current price, so we know neither the principal nor its 4-year value. So those are the two things we're going to be solving for. That's why it's a two-step problem. Now we know the interest rate is marked as 3%, and we know that the full term of the bond is 10 years. Next, we know that we're looking at it compounding semi-annually, so that's 2 times a year. And last thing is we know that eventually we're 4 years into it, so we've currently had 4 years pass. That's going to be necessary for the second part of this problem. The first thing we have to do is determine the principal or present value. And the way we do this is we act like the bond has 10 years to go from right now. That will tell us what it is worth at the very beginning. So we're going to use all the information and ignore this whole 4-year component. So we start with the $15,000 for the 10-year. We're going to use the compounding semi-annually and the interest rate, and we're going to act like we have 10 years to go on this bond. So that's the starting point. Where are we getting at the very beginning, as if we're going to go 10 years out from right now. So we're going to simplify our parentheses. So we add our two values together. This will give us 1 and 15 thousandths, and then the 2 times 10 gave us raised to the 20th. So I'm going to raise that to the 20th now, and then I'm going to divide the 15,000 by our value here of 1 and 346,855 millions, and that'll give us approximately $11,137.06, and I rounded to get to the 6 cents. Looked at my hundredth, I looked right one decimal place and then said I'm going to take it to the 6 cents. So now I have my principal, or I could call it my present value. Now with that, I can then go back and say, all right, I've got a principal. I know now I've got to go 4 years. So I'm going to use the 4 years with this principal to figure out what's the value for this current where I am. So now I can use my compound interest statement, where A is going to be that value that I'm trying to find. I have my principal, and now time passed is the 4 years that I'm into to determine its value. So I can use the $11,137.06. I've still got the 3% being compounded semi-annually. The big difference here is that now I'm using 4 because only 4 years have passed from the very beginning of when Erica started this bond. So I simplify my parentheses, and then I'm going to raise that to the 8th, and now I can multiply my principal by that value and get that it's $12,545.78. So that means that Erica would get $12,545.78 if she cashed that bond out today.